All right, I'm going to use the previous lecture to segue into another topic. The next section is on a topic called L'Hopital's rule. I'll talk about L'Hopital in just a moment, but let me sort of build a case for where we're going with this. So from our previous lecture, we had some function that looked like this. And we did a ridiculous amount of work so that we could come up with a graph that looked something like this. Okay, hopefully that refreshes your memory. Now, when we talked about this last time, I didn't get it terribly specific about what goes on with the function as it trails off this direction or as it trails off that direction. I was a little hand-wavy about that, and this is a really good time to talk about this in more detail. Because what we're really talking about is what happens to this function as x values get very large as they head off towards infinity, and what happens when you go very small with x values as they head off to negative infinity. When we have discussions like that, really what we're talking about are horizontal asymptotes. Are there values that the function gets really close to but never quite achieves? So let's just make a note of this. So conceptually, that's what we're talking about. But mathematically, we have a way of talking about that in fairly precise terms. If you want to talk about what happens as x heads off to infinity, then we're talking about limits. That's a mathematical way of representing this question up here. So let's explore that with this particular function. Function we've got, oops, sorry, still talking about a limit. Well, if I try and evaluate the limit right now as it is, I just plug in x goes to infinity, and I've got infinity over infinity, which is really annoying. We don't know what to make of that. Infinity isn't a real number. In fact, I really shouldn't have an equal sign. Let's just make this an arrow. This is what we call an indeterminate form. Which is a fancy way of saying we don't know what to do with this. But we don't have to just stop here, because it is true that as x goes to infinity, my numerator charges off to infinity and my denominator charges off to infinity. But do they get there at the same rate? How fast does the numerator and denominator go to infinity? Well, the fact that I said rate should tip you off here, because we've been talking about rates of change an awful lot, and it's deeply tied to the first derivative. So let's just jump straight to what L'Hopital's rule states. L'Hopital's rule says if we're trying to take a limit as x goes to some value, it doesn't necessarily have to be infinity. And the thing I'm taking the limit of looks like a big quotient, just like this does, great big fraction. And the result I get from trying to evaluate this limit is either 0 over 0 or infinity over infinity, these indeterminate forms. So if we've got a setup like that, then here's this fabulous trick that we can employ. The limit of this giant quotient is equal to the limit of the quotient of the first denominator at the top divided by the first denominator of the bottom. A very nifty rule, and we'll do an example in a minute that talks about, that shows this in use. But before I even get to the rule, I want to give you some warnings. You can't skip the intro to this rule. No fair trying to apply L'Hopital's rule if the original limit doesn't try and resolve into some indeterminate form, 0 over 0, infinity over infinity. You have to do that test first. If you don't do that test and try and blindly apply L'Hopital's rule, not only will you get the wrong answer, but you will be very harshly graded on a final exam. Don't make that screw up. Very important. The other thing I want to say about this is, just from a casual glance, if you're not paying attention, there's a real temptation to look at this and say, oh great, that's the way I've wanted to do the quotient rule all along. L'Hopital's rule is not related to the quotient rule. This is in no way whatsoever a shortcut for taking the first derivative of something that's set up like a quotient. It kind of looks like it if you squint and don't pay a lot of attention, but it's not really. Trust me, I don't know what else to say there. Don't make that mistake. The quotient rule still stands low d high minus high d low over low low. So don't make these two mistakes.